Hello geometry students, and welcome to another installment of Learning Geometry with your friendly neighborhood geometry teacher. Section number is 6.5. Title is Proving Triangle Similarity with SSS and SAS. Take a second and write that down. So you probably recognize SSS and SAS as congruence postulates. Now we are also going to have them for similarity, so be careful. So we should have done the inspire activity already, and moving right into it, we should have come up with SSS similarity theorem. So from the inspire document, we learned that, hey, if I have two triangles and all corresponding sides on my two triangles are proportional, then the triangles themselves have to be similar. Notice this is SSS similarity theorem. This is a similarity theorem. It can be proven. We're not going to do that right now. We may down the road, but right now we're just going to focus on the basics. So, in this case, if I know that AB to RS, that ratio is the same as BC to ST, which is also equal to CA to TR, then we can say all corresponding sides are proportional. Therefore, we can conclude triangle ABC is similar to triangle RST, and we would say by SSS, and instead of writing similarity, I put the little similar sign afterwards. Now, this little symbol is going to be important, because if you don't write it, I'm going to think you're trying to use SSS congruence postulate. That's not what we're using. We're using SSS similarity theorem. So, take a second, write this down, pause the video. We want to know, is triangle DEF similar to triangle ABC? Well, we don't know anything about the angles, so I'm not going to use angle-angle similarity, but I do have side measurements, so I'm going to try and use SSS similarity. So, let's check our ratios. So let's start with the shortest sides. So let's compare the shortest side of the first triangle, BA, to the shortest side of the second triangle, DE. You get a ratio of 8 to 6, which does reduce. 2 goes into each. That reduces to 4/3. Now let's look at the longest sides. Now I started with the triangle on the left in the numerator for this ratio, so I'm going to have to start with the triangle on the left for this numerator. So the longest side is AC over DF, 16 over 12, 4 goes into each, reduces to 4/3. And now, it's tempting just to say, oh, I bet the third is, but we better check it just in case. So the remaining sides that we have not used yet, BC and EF. So I get 12 to 9, 3 goes into each one of those, ratio 4/3. So we have a common ratio. We say corresponding sides are proportional. Therefore, we'll say triangle DEF is similar to triangle ABC. I just was making sure the order. We have to be super careful about that. We conserve the order here. So triangle DEF is similar to triangle ABC, and we say that by SSS similarity. Alright, do one more just like that. Stop, take a second, try this one by yourself. Alright, well, hopefully you got it, but if not, let's check it out here. Let's do the shortest sides. So I'm going to do AB to HG. 8 to 8 is 1. The longest sides, 16 to 16 is 1. Oh, we have a common ratio. They must be similar. Tempting to do, but let's check the middles. 12 to 10. Do I have a common ratio? No, I don't. So these triangles are not similar. These triangles are not similar. Alright, a little different now. Take a second, write this one down. Alright, now what I'm asking is, what value of x would make these two triangles similar? So, we need to have a common ratio. And notice the order. The order is important. I said A, B, C, D, E, F. So I'm saying AB and DE must correspond. BC and EF must correspond. So, let's set up a proportion. So the way the similarity statement's written, AB must correspond with DE. So I'll say 4 is to 12 as x minus 1 is to EF, 18. Now let's solve the proportion. 4 times 18, well, 40, plus 32 is 72, equals 12x minus 12. Add 12 to both sides. Kind of run out of room here. 84 equals 12x. Divide by 12. (84) divided by 12 is 7. So I get x equals 7. Now, technically I should probably plug that in down here. I should substitute that 7 in for x. 7 plus 1 is 8. 3 times 8 is 24. And does 24 fit with the rest? Because I need to make sure, do I have a common ratio? 4 to 12 is a third. 7 minus 1 is 6. 6 to 18 is a third. 8 to 24 is a third. So the sides are proportional, therefore the two triangles are similar by SSS similarity. Alright, we have another similarity theorem. Notice it's a theorem, not a postulate. We can prove this one. For the sake of the video, we are not going to prove it right now. Just sticking to the basics. So if an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides, including these angles, are proportional, then we can say the triangles are similar. Once again, we had an SSS congruent, so we need to be very careful. Either write the word similarity when you're using this, or use the symbol. So in this case, if x and m are congruent, and zx to pm is proportional to xy to mn, then we have side, angle, side, similarity. We can say the two triangles are similar by SSS similarity. Sorry, SAS similarity. So, we have a dilation. We've enlarged triangle XYW to JHK, and we're trying to figure out, are they similar? So let's check it out. Notice I had down here, because it couldn't really fit in the picture, so I had to give you some extra information. So XW is 16, JK is 24, YW is 18, HK 27, and then angle XWY is 80 degrees, angle JKH is 80 degrees. So we know we've got an angle. We've got the two angles congruent, 80 degrees, 80 degrees. So as far as the angle goes, check. That one's done. Now we need the two sides that form that angle. Are they proportional? So let's look at XW to JK. 16 over 24. 8 goes into each, is 2/3. Now let's look at the other pairs of sides. YW compared to HK. 18 to 27. 9 goes into each. So, side angles, we said that included angles were congruent, and another pair of sides proportional. So we can go ahead and say triangle XYW is similar to triangle JHK by SAS, and we're not going to leave it like that. We're going to say SAS similarity. All right, a little different here. We want to know, what method would you use to show that the triangles are similar? So looking at this first example here, just what method would we use? Well, can we use AA? Well, no, I don't have enough angles. Can I use SSS similarity? No, I don't have enough angles. I don't have the sides. So what I look at then is, could I use SAS similarity? Well, we know these angles are congruent because they're vertical angles. So then, are these pairs of sides proportional? 9 to 15, 3/5. 18 to 30, 3/5. So yes, this one I would use SAS similarity. Now for part B, look at what you have. We have no angles, we have only sides. So what would I try and use? I would try and use SSS similarity. So hopefully now we realize we now have 3 ways to prove triangles are similar: AA, SSS similarity, and SAS similarity. We'll see you in the next one.